So hi everyone, welcome back to another video of your course Math102B. This is your instructor, Engineer Janaika A. Tapiador. So in the previous video, we have talked about your functions. Now on your module number 3, we start with your calculus proper covering limits. So at the end of this module, the topic learning outcome is that you should be able then to discuss what the limit is and its relation to derivatives. So this will be the content of the module. So you have the introduction to calculus, the limit properties, computing limits, infinite limits, and limits at infinity. So as part of the introduction, I provided you external videos for your perusal that covers the topics on the introduction, average rate of change, instantaneous rate of change, and the limit of the function. So this is just for you to be able then to appreciate calculus and how it actually helps us in our day-to-day activities and life. The videos provided also showcase the important aspects that you need to know in order to understand and appreciate how calculus works. And I hope you have enjoyed watching them. Anyway, those are just, I think, 4 short videos with an average time of around 5 to 7 minutes. Now let's go to the limit. What exactly is a limit? We say that the limit of your f of x or the function of x is L as x approaches a, and we write it as this particular formula. So we read this as the limit of f of x is equal to L as x approaches a. So that's how it is actually read. Provided that we can make f of x as close to L as we want for all x sufficiently close to a without actually letting x be equal to a. Kumbaga parang x approaches a but x is not equal to a. So ano kaya itong L value na to kung saan yung x natin as it approaches a medyo magiging close to that value. So let's take a look at an example. We are to estimate the value of the following limit. So you have the limit of x squared plus 4x minus 12 all over x squared minus 2x as your x approaches 2. So paano ba natin ine-evaluate itong limit na to? Or rather, it says here, estimate. So as part of our solution, we will choose values of x that will get closer and closer to x is equal to 2 and then plug these values into the function. Doing this will give us a table of values which you have on the upper right of your screen. So kumbaga, di ba, dapat close to 2 lang siya. So yung mga plinug in nating values is 2.5, 2.1, 2.01, 2.001, 2.0001, and so on and so forth. So if you take a look, it's not really equal to 2, but values that are close to 2. And same is true with the right side of the graph. We plugged in values smaller than 2, but it's actually very close to 2. And if you take a look, what can you see from basing it from the graph? Itong mga values na to, kunyari, 2.5. So, if x is 2.5, sinubstitute lang dito sa ating main equation and then we get a value of 3.4. That's actually how it works. So, same is true if we substitute the value of 2.1 to x, we will get this particular value. Note that we made sure and picked values of x that were on both sides of x is equal to 2. So meaning, we plugged in values greater than 2 and then less than 2, but it was very close to 2 to make sure that any trends that we might be seeing are in fact correct. And also notice that we can't actually plug. So, hindi natin pwedeng i-plug si x is equal to 2 into the function simply because it will give you a 0 number. Diba? Pag plinagin mo yan, 2 squared plus 4 times 2 minus 12 divided by 2 squared minus 2 times 2 will give you 0. From this table, from the table that we have here, it appears that the function is going to 4 as x approaches 2. So, ibig sabihin, diba, if you take a look, parang papalapit siya ng papalapit sa number na 4 as we plugged in values that are actually very close to the number 2. So, parang halos papunta siya sa number 4. So, this means that the limit of the function x squared plus 4x minus 12x divided by x squared minus 2x as x approaches 2 is equal to 4. So, yan po yung sagot. How about we try then to graph the function? So, let's think a little bit more about what's going on here. If we try to graph the function from the example, then it will actually appear like this, diba? So, yan yung sa taas, ito yung sa baba, and this is at x is equal to 2. So, you first notice that there is a rather large open dot at x is equal to 2. Diba, pag nakikita nyo open yung dot doon, this is just to remind us that the limit does not exist at x is equal to 2. So, the limit exists as x approaches 2. However, at exactly 2, hindi po nag-exist yung limit natin. And as we are plugging values of x into the function, we are in effect moving along the graph towards the point as x is equal to 2. So, yung arrows dyan, pinapakita niya lang na as you try then to put in or plug in values that is very close to the number 2, yung arrows natin is magko-coincide po dun sa number na 4. So, in our case, we can see that x moves in towards 2 from both sides as the function is approaching y is equal to 4, even though the function itself doesn't exist at x is equal to 2. Therefore, we can say that the limit of the function is in fact equal to 4. So what have we learned about limits? It says here limits are asking what the function is doing around a particular number. In this case, we have x is equal to a, and we are not concerned with what the function is actually doing at x is equal to a. Also, this is a good thing as many of the functions that we'll be looking at won't exist at x is equal to a as we have seen in the example given. Now let's go to limit properties. So the time has almost come for us to actually compute some limits. However, before we do that, we need some properties of limits that will make our life somewhat easier. So let's take a look at those first. So it says here, we will assume that the limit of the function f of x as x approaches a and the limit of the function g of x as x approaches a exists and that c is any constant. Then we have your limit property number 1 such that if the limit of a constant multiplied by a function of x as x approaches a is actually equal to the constant multiplied by the limit of the function of f of x as x approaches a. So, yung pag may constant po dun sa loob, pwede mo na lang siyang ilabas. Yun lang po yung sinasabi ni property number 1. Property number 2, kung meron ka namang addition or subtraction between the two limits, tapos naka-enclose siya sa quantity, then you could just, parang pwede mo lang din i-distribute yung limit. Parang ganyan. Para maging ganito yung itsura niya. Third property, same is true with the multiplication operation. So, kung multiplication yan, pwede mo lang din i-distribute yung limit, tapos parang i-multiply mo lang din siya. Fourth, same is true with your division. As long as provided, ito po yung kanyang condition, as long as the limit of the denominator is not equal to 0. Kasi diba, pag minultiply mo yan ng 0, or rather, if you divide that by 0, it is in the indeterminate form. And of course, kung naka-exponential naman siya or it has an exponent, you could just go ahead and enclose the whole thing and then raise it to that particular exponent provided that exponent is a real number. Bakit walang 7? Anyway, 8, the limit of x is equal to a as x approaches a. And 9, the limit of x raised to n as x approaches a is a raised to n. Ito mga to, hindi naman kasi siya masyadong nagagamit. So let's go now to the computation of your limits. So let's try to evaluate the limit of the following. You have the limit of the function x squared plus 4x minus 12 all over x squared minus 2x as your x approaches 2. So first, let's notice that if we try to plug in the value x is equal to 2, we get 2 squared. Parang sinubstitute lang po natin yung number na 2. So we will get 0 all over 0, or it's in the indeterminate form. So hindi po pwedeng ganyan yung maging value ng ating limit. So we can't plug in x is equal to 2 to evaluate the limits, so we're gonna have to do something else. The very first thing that we should do always when trying to evaluate limits is to simplify the function as much as possible. In this case, that means we have to factor out both the numerator and the denominator, and upon doing so, it will give us this particular value. So, parang finactor out lang natin itong value na to, given as x minus 2 multiplied by x plus 6 divided by, sa baba, we factored out x, so that will be x multiplied by x minus 2. So, it's very important, dito nyo makikita yung importance po ng very good knowledge in your algebra. Such that, if you take a look, you could actually cancel x minus 2 and x minus 2 in the numerator and the denominator, leaving you with this particular simplified function. So you have the limit of x plus 6 divided by x as x approaches 2. Therefore, the limit is limit of x plus 6 divided by x as x approaches 2, and this time we could now plug in the number 2 in our limits such that you will get an answer equal to 4. So, ganyan po mag-evaluate ng limit. So, you try to simplify first your function and then you get the limit. So, let's try to take a look at another example. So, first, you have the limit of 2 multiplied by negative 3 plus h squared minus 18 divided by h. Now it says here, if you plug in h is equal to 0, this will also be in indeterminate form. So we need to simplify the function first by trying then to expand this such that you have the limit of the function 2 multiplied by the quantity 9 minus 6h plus h squared, quantity minus 18 divided by h. And then, you just distribute 2 to the whole quantity to provide you this particular function. So, itong 18 na to, tsaka yung 18 na yun, you can cancel out kasi 18 minus 18 is 0. And then, simplifying further, you could actually tawag dito, factor out h in the numerator such that you have limit of the function h multiplied by negative 12 plus h divided by h as h approaches 0. So, yung h dito sa numerator tsaka h sa denominator, pwede na pong i-cancel. And then, you will be left with this particular function. And of course, if you try to substitute 0 to the function, it will give you the answer negative 12. So, yan po yung sagot doon sa pag-evaluate nung limit. So, let's try to take a look at another example. So, given the following function, g of y is equal to 1 minus 3y if y is greater than or equal to negative 2. So, we are to compute the following, the limit of the function g of y as y approaches 6. So, usually, pag nakakita kayo ng ganitong function, medyo nakakagulat, but actually, napakadali lang nito. It says here, in this case, there really isn't a whole lot to do. In doing limits, recall that we must always look at what is happening on both sides of the point in question as we move towards it. In this case, y is equal to 6. It is completely inside the second interval of the function, and so there are values of y on both sides of y is equal to 6 that there are also inside this interval. So, ang ibig niyang sabihin, if y is equal to 6, di ba parang nagko-coincide naman siya doon sa ating condition na dapat yung y mo is greater than or equal to negative 2. So, since kino-conform niya naman itong condition na to, we could just simply plug in your 6 into the equation. Such that you will come up with this. The limit of g of y as y approaches 6 is equal to the limit of 1 minus 3y as y approaches 6. And plugging in the value of y, you will get an answer equal to 17. Or negative 17 rather. Sorry for the error there. Negative 17 po. Dapat yan. So let's go to the fifth topic of this particular video. You have your infinite limits. So in this particular section, we will take a look at limits whose value is infinity or negative or minus infinity. So this kind of limits will show up fairly regularly in your upcoming calculus subjects or topics, and you would need to deal with them at an earlier time. Actually, usually, pag nakakita kayo ng infinity, napakadali na lang po niya. So, no need to worry about it. So, the first thing that we should probably do here is to just define what we mean when we say that the limit has a value of infinity or minus infinity. So, we say that the limit of the function of x is equal to infinity as x approaches a. So, if we make f of x arbitrarily large for all x sufficiently close to x is equal to a from both sides without actually letting x be equal to a. And we also say that the limit of the function f of x is equal to negative infinity as x approaches a if we make f of x arbitrarily large and negative for all values of x sufficiently close to x is equal to a but not actually letting x be equal to a. So, mas ma-appreciate natin siya with an example, but let's try then to take a look at this. We are to evaluate each of the following limits. You have the limit of 1 all over x as x approaches 0 negative, and the limit of 1 over x as x approaches 0 positive. So, 2 lang pala to. In both cases, notice that we can't just plug in x is equal to 0. Because if we do that, we get division by 0. And what we do is to create a table plugging in values of x close to 0, but of course not equal to 0. And if we do that, we get this particular table. So kung mag-plug in ka ng negative 0.1, it will give you 10. Negative 0.01, it will give you 100, and so on and so forth. So, di ba kung nakikita nyo, habang pa-close siya ng pa-close sa negative 1 on this side, palaki na palaki naman yung value. So, we can say here na, it is approaching negative infinity or a very, very large value. And on the other side, if you try then to take a look, it approaches a very, very large positive value naman. So, ganyan siya. So, from the table, we can say that the limit of 1 over x as x approaches 0 positive is equal to infinity, and the limit of 1 over x as x approaches 0 negative is negative infinity. So, another way we can see this is by trying then to graph the function. And if you graph the function, magiging ganito siya. So, as your x values approaches approaches 0, yung y value mo palaki ng palaki yung kanyang value. So, kung makikita mo kasi at a very particular point, 'di ba, kung ang x value mo is 1, so dito lang sa banda. Pero pag ang x value mo is kunyari, yan, 0.01 or habang pa-close siya ng pa-close sa 0, di ba nakikita nyo tumataas ng tumataas yung inyong graph. That's for the positive 0. But for the 0 negative, pa-negative ng pa-negative yung value. But you can see that pataas ng pataas yung inyong y value as indicated here in the graph. So in summary here, these are the values of both the limits for this example. So yan po yung sagot dun sa ating function. How about limits at infinity? So in the previous section, we saw limits that were infinity, and now it's time to take a look at limits at infinity. By limits at infinity, we mean one of the following two limits. So, paano ko naman kung yung limit of f of x as x approaches infinity and the limit of f of x as x approaches negative infinity. So, in other words, we're going to be looking at what happens to the function if we let x get to a very, very large positive or negative value. So many of the limits that we're going to be looking at, we will be needing the following two facts. Number one, if r in this particular equation is a rational positive number and c is any real number, then you will have the limit of a constant divided by x raised to r as x approaches infinity is equal to 0. And if r is a positive rational number and c is any real number and x raised to r is defined for x less than 0, then we mean that the limit of a constant divided by x raised to r as x approaches a negative infinity or a negative large value is equal to 0. These two are very important principles as you will be seeing later on pag nagsagot na po tayo ng problems regarding limits at infinity. So let's take a look at this particular example. So we are to evaluate the following limit. The limit of the function 2x raised to 4 minus x squared minus 8x as x approaches infinity. So usually our first thought here is probably to just plug infinity into the polynomial and evaluate each term to determine the value of the limit. So let's see what happens if we do that. So, meaning, pag plinug in natin, 2 times infinity, magiging infinity, minus infinity squared is negative infinity squared, minus 8 times infinity, which is infinity. Infinity minus infinity minus infinity, hindi natin talaga madedetermine yan. So, it's in the indeterminate form. So, as with the examples that we had previously, we should first simplify our function para ma-evaluate po natin yung limit. Doing that, you will have this. So let's try to factor out the largest powered variable here. So in this case, yung pinaka-large na power is your x raised to 4. So yan po yung finactor out natin dito sa ating function, such that you will come up with this, the limit of the quantity x raised to 4 multiplied by 2 minus 1 all over x squared minus 8 all over x cubed, quantity as x approaches infinity. At this function, pareho lang dito, finactor out lang natin si x raised to 4. Kung nag-aalangan kayo, edi try nyong i-distribute ulit yan. And then, if you try then to distribute that, you will still go back to this particular function. So, pareho lang, or rather, yes, function. So, pareho lang po silang dalawa. So, this is very important kasi mas madaling i-evaluate ang limit pag ganito yung kanyang form. Diba? So, now that we have that particular form, what can we do? So, pwede na po natin silang paghiwalayin such that you can say that the limit of x raised to 4 as x approaches infinity is infinity. So, that is already a fact. And the limit of this particular function is actually 2. So, paano po nangyari yan? Diba? If you try then to distribute the limit here, so the limit of a constant is the constant itself, and then the limit of negative 1 all over x squared is 0, and the limit of negative 8 all over x cubed is 0. Paano ko po nalaman na 0? Yun po yung fact number 1. So if we try then to go back, ayun, nalampasan na. Ay, or bumalik ako. Wait lang. Yan. So, diba, fact number 1, if or, parang ganito na yung kanyang itsura, diba, you have a constant divided by x raised to a particular positive rational number, then that particular limit is equal to 0. Or kung negative infinity din naman yan, 0 pa din siya. Such that we were able then already to evaluate na yung sagot doon sa ating limit, ayan, is equal to 2. Dito lang sa function na to, ha? Therefore, the limit of x raised to 4 as x approaches infinity is infinity multiplied by the limit of 2 minus 1 all over x squared minus x all over x cubed as x approaches infinity is 2. So, infinity times 2 is equal to infinity. So, ibig sabihin, if you evaluate this particular limit, you will come up with the answer equal to infinity. Pero that's not always the case. Pwede kayong makakuha ng ibang value aside from infinity. You may get 0 or any positive rational number. So, fact number 2. So, this is of a polynomial with a degree n. Ginawa na natin to kanina. But it's easier for you to understand this if we have an example. So, taking a look at this particular example, you have the limit of the function 2x4 minus x squared plus 8x divided by negative 5x raised to 4 plus 7 as x approaches negative infinity. So let's start with the first limit, and as with our first set of examples, it might be tempting to just plug in the infinity. But since both the numerator and the denominator are polynomials, we could use the above fact to determine the behavior of each. So doing this will give us this particular value. So if you try then to plug in infinity in both your numerator and the denominator, you will come up with this answer, infinity divided by negative infinity, which is of course indeterminate. So what do? We first of course simplify the function. How do we do this? When we have a polynomial divided by another polynomial, we first identify the largest power of x in the denominator. And yes, may I reiterate this, to look at the denominator. And we factor this out, both of the numerator and the denominator. Sa denominator lang tayo titingin. And whatever is the largest power of x in the denominator, that's what you will be factoring out. So if we do that, we factor out x raised to 4 on both the numerator and the denominator, you will be coming up with this particular equation. And kung ganyan na po yung equation, pwede na po natin siyang i-simplify. We could cancel out x raised to 4 here and then x raised to 4 there. Then you will be left with this particular function. And if we try then to evaluate further, we could simply plug in negative infinity into the equation. So magiging ganyan. And of course, alam nyo na to from fact number 1, this will be equal to 0. This is also equal to 0. And this is equal to 0. So that will be 2 minus 0 plus 0 divided by negative 5 plus 0, or that's simply equivalent to negative 2/5. So this is a perfect example. As you can see, hindi siya palaging 0 or hindi din siya palaging infinity porque may makikita kayong infinity na symbol. So that's it for this particular video. Please start working on your activity that is actually set in your canvas. Thank you, guys. And as I always say, stay home, stay healthy, and stay safe. Goodbye, everyone.